If you could communicate with an alien civilization, you wouldn't start with English or music sequences from a movie. You would start with numbers, but not just any numbers. You would send a specific value that appears everywhere, from the structure of hydrogen to the way atoms interact with light. That number is roughly 1 over 137. This dimensionless constant, known as the fine structure constant, or alpha, is the ultimate gatekeeper of the physical universe, determining whether matter can even exist, or if the cosmos would simply be a featureless soup of radiation. It is perhaps the most famous number in physics that nobody in the general public really talks about. Yet, it keeps the sun burning and your cells together. Richard Feynman, one of the greatest minds of the 20th century, called it one of the greatest damn mysteries of physics, and suggested that all good theoretical physicists should put this number up on their wall and worry about it. The mystery exists because 137 isn't something we calculated from a deeper theory. It is something we measured. And we have no idea why it has the specific value that it does. To understand why 137 is so special, we have to look at what it actually represents. Technically, it is a measure of the strength of the electromagnetic interaction between elementary charged particles. It relates the charge of the electron, the speed of light, and Planck's constant. When you combine these fundamental constants in a specific way, all the units of measurement, meters, seconds, kilograms, cancel out perfectly. You are left with a pure number, a dimensionless ratio. This is incredibly rare in physics. Most numbers we deal with depend on the scale we use. The speed of light is 299,792,458 if you use meters, but a completely different number if you use miles. But alpha is roughly 1 over 137.036, no matter what planet you are on or what units of measurement you invented. It is a universal constant of nature that appears to be baked into the very fabric of reality. If this number were even slightly different, the universe as we know it would vanish. If alpha were 1 over 138 instead of 1 over 137, the fusion process that powers stars would be disrupted. Carbon would not form in the hearts of dying suns. And without carbon, there is no organic chemistry and no life. The history of this number begins with Arnold Sommerfeld in 1916. While attempting to explain the fine details of the light spectrum emitted by hydrogen atoms, he noticed that the lines aren't just single bands of light. When viewed through a high-resolution spectroscope, they split into clusters of smaller, thinner lines. To explain this splitting, he had to introduce a new constant into his equations that accounted for the relativistic effects of electrons orbiting the nucleus. He found that the velocity of an electron in the first Bohr orbit of a hydrogen atom, divided by the speed of light, resulted in a value very close to 1 over 137. This was the first hint that 137 governed the internal architecture of the atom. It defined the gaps between energy levels, essentially dictating the color of the universe. Every time you see a neon sign or the blue glow of a LED, you are seeing the fine structure constant in action, as it determines the exact energy of the photons being emitted. As quantum mechanics evolved, the significance of 137 only grew. In the world of quantum electrodynamics, or QED, alpha represents the probability that an electron will emit or absorb a photon. Think of it as the coupling strength. If the number were larger, the attraction between electrons and protons would be so violent that atoms would collapse or be too tightly bound to form complex molecules. If it were smaller, the electromagnetic force would be too weak to hold electrons in orbit at all. Matter would simply disintegrate into a chaotic cloud. This creates a fine-tuning problem that haunts physicists. Why 137? Why not 10 or 100? Or 1,000,000? Wolfgang Pauli, a pioneer of quantum physics and a Nobel laureate, became so obsessed with 137 that he spent his final days in hospital room number 137. A coincidence that he noted with grim humor before his passing. He believed that if he could explain why this number existed, he would understand the mind of the Creator, or at least the fundamental logic of the cosmos. The mathematical curiosity of 137 goes even deeper when you look at how it bridges the gap between different branches of physics. It is the intersection of three major pillars: electromagnetism, represented by the charge of the electron; relativity, represented by the speed of light; and quantum mechanics, represented by Planck's constant. Because it sits at this crossroads, it is the ultimate test for any theory of everything. Any physicist who claims to have unified the forces of nature must be able to produce the number 137 from their equations. So far, no one has succeeded. We can measure it to incredible precision, down to 10 decimal places, but we cannot derive it from first principles. It remains an empirical input of value we have to plug into our machines because the universe told us to, not because we understand the reason for its existence. Some theorists have looked for the answer in the geometry of space itself. There is a long-standing fascination with the relationship between 137 and the number 137.035999. In the mid-20th century, Arthur Eddington attempted to prove that the reciprocal of the fine structure constant had to be an exact integer, specifically 136, and later 137. He argued that it was related to the number of degrees of freedom in the universe. While his specific proofs were eventually dismissed as modern measurements moved away from the perfect integer 137, the psychological impact remained. Even if it isn't exactly 137, the fact that it is so close to a prime number that appears in various mathematical contexts fuels speculation that we are missing a geometric link in the study of packing spheres or the distribution of prime numbers. 137 occasionally emerges in ways that feel more than coincidental, though mainstream science remains cautious about these numerological overlaps. Consider the implications of 137 for the survival of life. The triple alpha process, which is how 3 helium nuclei fuse to form carbon, is extremely sensitive to the strengths of the fundamental forces. This process relies on a specific resonance, a state of energy that allows the fusion to happen efficiently. If the fine structure constant were shifted by just a few percent, the stars would either burn through their fuel in a matter of millions of years instead of billions, or they would never produce carbon and oxygen at all. We would be left with a universe of hydrogen and helium, a sterile expanse where nothing interesting ever happens. This has led some to suggest the anthropic principle. Perhaps there are many universes with different values for alpha, and we just happen to live in the one where the number allows for observers to exist. However, for most physicists, this feels like an admission of defeat. They want a mathematical reason why 137 is the correct answer for reality. In recent years, the mystery has taken an even more startling turn with the question of whether 137 is actually constant. Some astronomical observations of light coming from distant quasars, billions of light years away, suggest that the fine structure constant might have been slightly different in the ancient past. Researchers looking at the absorption lines of metal ions in these distant gas clouds found a tiny discrepancy, suggesting that alpha might vary depending on where you are in the universe or when you are looking. If this is true, it would revolutionize physics. It would mean that the laws of nature aren't fixed, but are part of a changing landscape. However, these results are highly controversial and difficult to replicate. Most current data suggests that if alpha changes, it does so by less than 1 part in a billion over the course of the universe's life. For now, 137 remains a stubborn, unmoving pillar of our reality. The number also appears in the context of the maximum atomic number. According to the Dirac equation, there is a limit to how many protons a nucleus can have. As the number of protons increases, the energy of the electrons in the innermost shell changes. When the atomic number reaches 137, the model suggests that the electrons would need to travel faster than the speed of light to maintain their orbit. This suggests that element 137, often jokingly called Feynmanium, could be the absolute end of the periodic table, while relativistic effects and the non-point-like nature of the nucleus allow for some wiggle room. 137 acts as a theoretical barrier, a boundary beyond which the traditional rules of matter and atoms start to break down and fall into the vacuum of the Dirac sea. Mathematical beauty and physical reality often mirror each other. And 137 is the most profound example of this. It shows us that the universe has a preference for specific ratios. It suggests that there is a deep, underlying code to the cosmos that we are only beginning to decrypt. Whether it's the way light bounces off a mirror, the way a snowflake forms, or the way a star dies, the fine structure constant is there, quietly holding the variables in place. It is the ultimate bridge between the abstract world of numbers and the tangible world of things. It reminds us that we live in a universe that is not just a random collection of parts, but a highly tuned system governed by constants that are as precise as they are mysterious. To wrap up, 137 is more than just a digit. It is the fingerprint of the universe's design. It sits at the heart of darkness and light, matter and energy. While we may not yet have the mathematical key to unlock why this specific value was chosen, the search for the meaning of 137 continues to drive the most advanced theories in modern physics. From string theory to loop quantum gravity, it challenges us to look deeper and ask why the universe is the way it is. If you want to dive deeper into the hidden patterns that govern our world, consider looking into the geometry of the golden ratio or the distribution of primes. The more we look, the more we realize that the universe is written in a language of numbers, and 137 is one of its most important words. If you enjoyed this exploration of the foundations of reality, make sure to look for other patterns that connect the cosmic to the microscopic.